Before they come up on screen, I will quickly give a short idea of what they will be talking about. They will be talking about logistics, the fascinating world of logistics. Especially, we will have Manfred Rieck, who is head of quantum tech, and we have Ronald Bieber, who is expert on quantum security, both work at Deutsche Bahn, and they will give us an idea about the strategic relevance of quantum computing for logistics, but not only for logistics. So I'm happy to now welcome both of them here on stage. Welcome. The floor is yours now. Thank you.
Yeah. Thank you very much. I apologize. Ronald has become ill over the last night. He caught one of these viruses, you know, and so therefore I take over the second part, this security part as well. So hopefully I can fill what he did in the past and bring the message to you, what it means. So. Over the last week, we changed the title a little from strategic relevance of quantum computing only for logistics towards the not only for logistics companies, because we are covering two topics, the optimization topic on one hand and the security topic on the other hand. So what we try to show you is what does it mean for us? How do we what do we think as Deutsche Bahn about quantum computing? What's our resume after working since 2.5 years now with this topic? And when we first have a look at the market in these quantum activities, we see it is growing. It is not declining, it is growing. It's right the opposite. So North America is the largest market at the moment, one of the largest markets. We see some large organizations over there. We're investing the quantum computing, we're dominating the quantum computing market. We see China, we hear a lot of China, what they are doing in the communications market. We are not aware really what they are doing in the computing part. And when you look for the funding in the US, $2 billion, in China, $15 billion, and in Europe, 7.2 billion euros, and 2 of these billion euros are from Germany. And what we figure out is at the moment that component manufacturers are doing a good business. They sell whatever they can to build up the systems. We see a lot of consulting companies hunting for use cases since 2 years now. Where can we use quantum computing in the industry? And a lot of consortia are raising up and come together from industry and from research. In Germany, it's, for example, Fraunhofer and DLR, together with the industry, building up these consortia and working on quantum computing. So when we have a look at the worldwide market, we prepared here something with some names of more or less well-known organizations in the US, D-Wave with the ANILA. We have an ANILA already in Germany now. Honeywell came up, AWS came up with this bracket platform. We assume they build up an own quantum computer as well. IBM with the IBM Q, we have an IBM Q in Stuttgart now. Microsoft is building something. Nobody knows really what they are doing. And Google X from Alphabet is building a quantum computer as well, which can be used and which can be tested from the community. When we look for the Asia area, we see China with its platform companies, Baidu, Tencent, Alibaba. We know them from other areas. They're building up something around quantum computing. We're not really aware what they are doing. And what's very interesting for us is the Japanese area. We have a Quantum Star Alliance in Japan with 21 organizations, Toshiba, for example, Fujitsu, all the Mitsubishi is there with all the large companies figuring out what quantum computing means. And having a closer look at Europe, we see on one hand the flagship. I suppose Tommaso has already in this meeting and give an overview what the flagship is doing. And we have the Quick organization, a consortium of now around about 150 companies all across Europe, having the goal to make quantum computing happen in Europe for us, for the industry. building up roadmaps for quantum computing, for the research, to let them know what we need from an industry perspective. And Deutsche Bahn is part of the governance board, so we are really interested what happens there and how we can use it for us. And having a closer look at the German area, here is only a subset. We know in Munich, the Munich Quantum Valley has established some years ago and is using now the IQM system, or building up the IQM system from IQM. The Planck consortium, I suppose Planck has a speech here as well, where we are a member, is in Germany one of the largest software development projects for quantum software, not for the hardware, for the software side, which is really important for us, because we are very interested in what is happening from the software perspective. And from a security perspective, the DIFQ-SEC, the German Industrial Association for Quantum Security, has been built up beginning of last year. So everything is very new, what you see here. So the groups are emerging, the corporations are coming together, and we are still in an early stage, but what we see is it doesn't go away. So 2 years ago now, January 2020, we started with Planck. 1 year later, the first system has been established in Munich, in Stuttgart. The IBM Cube is available. We got the signature from ministry to build up the IQM system in Munich, in the LRZ, together with a high-performance computer. We've got the Eagle system 1 day later announced with this 127 qubits. I know the number of qubit doesn't really say how fast it is and what it is possible, but it shows that the industry is still keeping its roadmap, and I assume IBM is keeping the next step as well. And in January, we've got the information that the D-Wave system is up and running in Jülich. And so we see on the quantum hubs, there is a lot of traffic, a lot of experts are coming together and working on it. And so therefore, as I said, it doesn't go away. What have we done within Deutsche Bahn? Within Deutsche Bahn, we have a so-called digital and technology strategy, where we figure out which relevant technologies can be used from a logistics organization, from an IT and logistics organization in the future. And this is mapped into a strategic roadmap, and their quantum computing has become one part right at the beginning, 2020, when we started with the Planck project. So there it is anchored in the organization. And we built up a team working on the optimization part and on the security part to figure out what does it mean for Deutsche Bahn. So on one hand, we have the experts in the own organization, and on the other hand, we are very, let's say, very close together with the network, with the quantum network, which is still raising within Germany, within Europe. So we have the strategy strong rail, which means we need to double our passengers within the number of our passengers within the next years. So this won't be possible by building up some tracks within some years. It take a lot of time. So therefore we need a technological approach. And we assume that quantum and KI, AI, could be an approach to support this strategy with technology. With this strong industry network and with round about 330,000 employees and 50 million passengers per day, we assume that we are one of the power users. We will become one of the power users when the problems, when the computer science problems, the serving tradesman problem I show you later on, when they are solved with quantum computing. So this is our expectation. And we are very happy to be part of it right at the beginning, to bring our logistic experts on one hand, who know how logistics does really work, and the technological experts right at the beginning together and work on the technology. On the other side, we are a critics organization. We have several OT and IT structures in the organization, which need to be, let's say, we have to know what happens when quantum computers are available to them. So therefore, we need to be prepared and are active in this DIFQSEC organization. So you see, on one hand, we have two pillars. On one hand, the opportunities, the optimization of our rails, of our personnel, of our trains, of our assets we have in the organization. And on the other hand, the threats when the computers come over and are able to burden our systems. I would like to show you a short use case we've implemented right at the beginning, just to give you a view on what happened. So we built up a QUBO. It was a very small experiment to figure out whether it works or not. So important for us is not to stay on a theoretical way, but to figure out what does it mean in reality. So we have our developers, the quantum developers in the organization. They took some real data, a handful of stations, a handful of trains and some rides. And with this first approach, we come over that we need on a D-Wave 200,000 qubits. That's a lot, but we have only figured out the first number, which could be helpful for us when we working for the future with a larger system. And just to give you a view what larger system means, most of you know it, the traveling salesman problem, just mapped to the Deutsche Bahn environment. When you plan a trip as short as possible, you try to visit several cities. For us, these are the stations. And you assume that one city costs you 1 nanosecond. You start with 5 cities. It takes you five cities, 5 stations. It takes you 12 options, so 12 nanoseconds. When you double the number of stations, you have already 180,000 possibilities. So you are already in the millisecond environment. And when you double this number again, 20 stations, you have a calculation time of already 2 years. And we have 5,500, around about 5,500 stations in Germany. And these are only the stations. When you look for you're adding the tracks, you're adding the trains, you're adding our personnel, our staff, then you become aware of which complexity our people are working with and what they are doing. And therefore, we expect that quantum computing could be really a solution for us when we try to get further. Coming to this cryptography and cryptography topic. So I suppose most of you know this Mosca's theorem. So question is, how long does it take to migrate our infrastructure? So this is one question which has to be raised toward the CIO, the CISO and CIO. How long does it take? The CEO is usually asked, CEO and CFO, which relevant data need to be secured and how long? Not the emails, but maybe some finance data in organization, which have to be left and kept in the organization in a secure way. And the quantum expert is usually asked, how long does it take to build up the system? And what we've learned over the last 2.5 years is you're asking 2 experts and you get 3 answers. But what really relevant becomes for us is the exchange with other organizations, with other industrial organizations. And we came to the conclusion that the time frame when the quantum computer, the large quantum computer will be built up is maybe not the problem. We should have a look at how long does it take to bring our systems on the next level. For example, enable them to become crypto agile, enable them to change the algorithms which are not really known, the quantum resilient algorithms which are really not known, but enable the organization upfront to change the systems afterwards, maybe in a factory approach or whatever. And this is what we are doing at the moment. So what we assume is, and this is what the European Agency for Cybersecurity promoted already 1 year ago, that there will be a system somewhere, and some of us will be astonished that it is already available. And this means that we need to be prepared right now. And this is what we are already regularly discussed with the BSI, with the organization which is relevant in Germany for the security activities in the organization. And there we see on the one hand that the NIST organization, this National Institute, which is organizing the race, or the race on which algorithm can be used for the future. The NIST would be ready within the next, we suppose, 2 years, 2024 maybe. What we see on the other hand is that the BSI has given out some papers and got us the recommendation to start right now. So don't wait for NIST, but start with what the BSI recommends us, and start to enable your organization to make them aware that they have to handle this issue which will come up. We suppose it will come up like the pandemic we experienced 2 years ago, 2.5 years ago. We have known that there will come a pandemic, but we weren't prepared for that. And therefore, crypto agility is one of the topics we are implementing at the moment in the organization, with recommendations from BSI. You see the classical Mega Alliance and the Frodo-Chem, just to make our people aware and to let them know how this process will work out in the future. So we don't know really which algorithms can be used and how they will be available, but we know that we can prepare the organization, especially large organizations, by doing an inventory first, because large organizations in most cases doesn't have only one PKI system. They have several PKI systems, and maybe it is not in every case clear how the system is working in other countries, for example, and what they are doing. And on the second step, you need to discuss with your suppliers, are they prepared or not? Do they have it on the radar, or is it still something for the suppliers as well, which comes within the next 10 or 20 years maybe, and where they are not prepared and where you are not got an answer? And especially when you're working with tenders, as we do as Deutsche Bahn, then we have it in our tenders that this need to be a point of them, and that this need to be considered. And then for us, it is important to test the algorithms for us and to learn how it works. And as we do it here in the summit, to spread it across the community, within the IT community, for example, with other organizations as well, to make them aware that there is something coming up, and that we can wait on one hand and are astonished that it will be there. On the other hand, now we have the time to prepare us. It takes money, needs money for this is what we know, but it is necessary. And therefore, my recommendation is to start these activities and come together and use, for example, the Bitcoin community, to exchange how to deal with this. So this is the resume for us. We are on one hand looking for the ecosystem. We are really interested what they are doing. Now we are looking more deeply in the US ecosystem. within the next events, taking part with them. Then we are doing some experiments, some small size experiments, and we implement the crypto agility. Now I see.
Wonderful. Thank you very much for this. I think we are seeing slides now again. I think this was, now here we go. All right. Thank you so much for your insights. Also giving this kind of communicating this level of uncertainty. I think this is a key element here, how to deal with this in your daily work as well, and how to communicate it.